Greetings, welcome back to Randomtronic. My name is Chris and today I will be putting together a very unusual and very cool DIY kit. This came from Banggood, a bag of parts, an antenna and a USB cable. And this is a software-defined radio kit, not only the USB little dongle that you'd normally put into the USB of your computer and then run SDR software. It also involves some other components and some RF interesting magic to improve the response or the frequency range of the SDR radio. So let's assess what we have. A mini USB cable. This is used to communicate with the computer and to power the unit. We've got an antenna, and compared to the one that I've had on the previous SDR kit or SDR receiver, this one looks somewhat better. It's got a little spring in the middle. I guess that's doing something. What I really like about this, and it makes this kit special, is we get a standard USB SDR dongle. We get to take it apart, then solder it into a different project. That's an unusual way of sourcing parts. The PCB itself is really nice. There are lots of vias. I'm sure this is some sort of RF magic filtering something happening. There will be a few air coils that we need to wind up, and there is some enamel coated wire provided. Three types of wire. So we've got a thick copper one, a silvery one medium thickness, and really thin enamel coated copper wire, and a bag of parts. Two SMA connectors, a jumper, a USB socket, two electrolytic caps, or three actually, one bigger one, diode, 6 pieces of cut tape of some surface mount components, 3-pin header, and the metal casing, because this whole thing has got a really nice metal case. Nearly forgot, there's a tiny little ferrite bead, and I think we will be winding up a little transformer on this. So hey, exciting. So we're supposed to pry this apart first and get this ready to be mounted into the main board. Pry apart the thing. If you look closely, it looks very similar to the blue dongle that we've torn apart recently. So let's begin by removing the large connectors first, and I will be using NC559 flux. I've not used it before, but let's see how that performs. There's a huge thermal mass in the form of that connector, so it will take a moment to get this heated up. Okay, we might be free on this side, and let's do the same with the other side. So let's see. Well, yeah, this is already wobbling, and done. And let's put some alcohol to clean this up. So now we can remove maybe this guy and remove the USB connector. Well, look at that blob. That's like a Death Star. Okay, easy. And next we've got a few components to put on, and I'll begin with the USB port. That should go right about here. And let's do the other side. This is the first time I'm using this flux, by the way, and so far positive impressions. Because it's a big ground plane, you can see over here. Yeah, it takes some time to get the heat into the ground plane to get the solder to wet, but yeah, there we go. It's done it now. Okay, that looks to be soldered. Everything, as you can see, is very nicely silk screened on the PCB, so it should be somewhat easy to identify which component goes where. Right, let's see how's that gonna work. Well, not very well. So what I'm gonna try to do is I'm going to tin the pads, then place the capacitors onto the pads, and then hot air them and see if that works. So first some tin, then add some more flux, because why not, and place the components. That works the treat. The nice thing about doing it with hot air is you don't have to be so precise, because the surface tension pulls the components right into the right place. Okay, let's hope that works. That flowed in nicely. And here is the effect. Not too bad. Some bits I've given a bit too much solder and some were just right. So yeah, learning in progress. I was using surgical spirit. I've got pure IPA somewhere in the attic. I need to get it down because this stuff doesn't seem to be cleaning up all the flux properly. Good enough for now. Okay, and we are a few days later and I have a little bit more time to finish this, hopefully. So let's continue by placing all the remaining components, this time the through-hole ones. And the LED, I want to make sure that it sticks out through the front just enough, like so. So we don't want it to be like this, hiding right in the somewhere in the background. So I want it fully pressed into the front of it. So this is more or less what I'm talking about. Next, according to the instructions, we need to make 2 low-pass filters, or 2 coils basically. We're going to use the copper colored wire, the thicker one, and just like in the instructions, we're going to take a 5mm twist drill and use that as a former 8 turns. So let's do that. And here are the 2 inductors. I'm gonna keep them on the drill bit and put them in a vise with rubber soft jaws, and I can trim the leads a little bit and then try to tin them. That will strip the coating from the wire, make it easier to solder. So to do that, I'm going to just bump up the temperature. Actually, I should change the tip. Here's a slightly better angle so we both can see what's happening. So in theory, we should be able to apply just hot solder. I've put the temperature on the iron up to 400 degrees, so it's a little bit hotter than normal, but that should melt off the coating. So I'm just going to put a ton of solder on the tip, and there we go. And because the coil has still got a little bit of springiness to it, so as you can see, the leads are straight, but when I let go, they kind of spread a little bit. So I'm still going to use the drill bit until I fully solder it in. That's one. We're probably just going to have to use a knife to spread those evenly so it's nice and straight. And there we go, that's done. Pretty. To mount the smaller board inside the bigger one, I think what I'm going to do is use a few points, like here for the signal going to here, and then I think those are ground pins that will be connecting to these points. Use a little bit of this silver wire and just solder in small sections in here, which I can then use to bend over and solder to those points. This will kind of make it easier to hold this in the middle of the rest of the board. And with the board prepared like this, put it into the cutout, ready to be soldered in, and it kind of stays in place, so that makes it easier to keep it nice and level with the rest of the contraption. Now I think the instructions ask to flood those solder pads and basically bridge both boards together. So let's see if we can get that done. Time for a few jumpers, and all of those will be made using the rest of the silver wire. The 3 holes over here need to connect to this one, and this one correspondingly. Then this +5 from this capacitor, this hole here, we need to make a jumper that goes up and above and to this side of this capacitor. And likewise on the back side, this hole needs to have a wire that goes up and above and connects to this side of this capacitor. So I'm holding the wire from underneath using my one hand, and I've got a little bit of the solder on the tip, and keeping it in the right position, like so. I'm just going to tack. Right, I think that worked. Okay, that is a success, I think. And that's the second one. And here is what it should look like finished, or not finished, but connected with all the jumpers. So here is the top. We've got 3 jumpers by the USB and 1 from the plus 5 volts to the cap on the board, and on the back side there's 1 jumper going from the cap to another supply voltage point on the main board. Now the dreaded transformer, then we need to connect the transformer from those pads to the legs of this chip. And according to the instructions, oh geez, this is so thin, we need 3 windings. And the instructions say to first fold the wire into 3, twist the wire together into 1 strand, and then use that to wind the 8 turns on the ferrite core. So we ended up with something like this. Very nicely uniformly twisted 3 lengths of thin enamel coated wire. Now I need to wrap it around the core 8 times. And here is the transformer wound. Now comes the fiddly part of marking up all the windings, what is what, and getting it connected according to the instructions. So we need to connect the transformer like in this schematic diagram. And what that means, 1 coil, or the primary, as a 1 winding. The secondary consists of 2 other windings, effectively in series. So let's get the multimeter into the buzzer mode and work out what is what, hopefully. I'm going to put a small piece of double-sided tape in the middle to hopefully help me hold the transformer down a little bit. So here it is, and it's meant to go like this. Okay, I think that caught nicely. Right, let's buzz it out if we got solid connections. Yep. Yep. And across, of course, nothing. Okay, here we go. So this is the fiddliest thing I have ever had to solder. Ever. I mean, yeah, this is small. Look at the tips of the tweezers. Here is the scale of what we're looking at. I've pre-tinned a tiny bit at the end of the wire. What we need to solder those two is pin 4 and 5. Doesn't help, it's right past this capacitor or resistor, whatever that is. I think it's a resistor, but yeah, it doesn't help that this guy is right in the way. However, let's flood this with flux. Okay, we've got it on pin 4. I'm not sure I've even touched it with the iron tip. Okay, I've added the tiniest amount of solder at the end of the wire. I'm gonna have to change the flux in a moment because it's beginning to burn out. Oh, I got it. But where? I really don't know where I got it. That's the problem. Because of the reflection, I think it's on the right leg. Yeah. That's about right. I used some nail polish remover to clean it up and too hot. I thought nail polish remover was going to be a good idea, but it wasn't. It had some water, so I reached for hot air gun and it was too hot and it desoldered my wire. How annoying. I just ordered 5 liters of isopropyl alcohol, and because I do have a bottle somewhere, I spent like half an hour today looking for it, but to no avail. So yeah, new supply is the way to go. Be quicker to buy a new one than find the previous one. Okay, that's actually better than the first time, so okay, that's quite solid. Happy with that. Let's do the other leg. Oh, look at that. Oh, spoke too soon, but I'm becoming somewhat efficient at this. There you go, check it out, done. It's not all that difficult once you get a little bit brave with it. So now this basically is just a loop of wire, but I can now cut it to length, tin the top end of it. Oh no, oh no. And we were so close. I've done it this many times, I can do it one more time. There we go, first go. I am proud of myself. And now let's figure out which one goes where. According to my understanding of what was going on, pin 4, so this one here, I know I need to connect my one onto this, like so, and the other one over here. So here is the end product, and the wires are connected. I did made a mess of it a little bit, but that's okay. It will clean up with proper isopropyl alcohol when I find it, or when it arrives. But this is, in essence, is now complete. So despite having a little bit of flux residue all over the place, I don't care. I want to plug this in and see it work. Then I guess in another episode we'll try a different antenna, because again I'm not expecting great things off of the indoor antenna that came with this. Before we do, let's put it in its proper enclosure. I really hope this works. I mean, I've done everything I think properly. You see, this kit was a huge amount of fun to build, and this, by the way, I'm gonna leave in the P position, so jumper on this side, and that's without outputting the power to the LNA, because we'll be using an antenna without an LNA. So yeah, keep it that way for the time being. It's a really nice box. Okay, this is complete, so let's see if it powers up. Okay, I heard a discovery of something, so the USB part works and the LED came on, and voila, it does work. I've connected the antenna to the 25 megahertz to 1.7 gigahertz, and again the similar stuff like last time. Let me make it a little bit louder. Of course we need a proper antenna. Right now I've got it connected to this whip, which actually is magnetic, so yeah, it might as well stay here on top of the monitor. Of course you can receive a normal FM broadcast, as you can see, and yeah, BFM is the broadcast FM, and you can easily catch on to different radio stations. I'm gonna move away from this before YouTube marks this as copyright material. What was that decoding? Oh, this decodes the RDS data. How cool. I don't know what it is. I'm getting a feeling that I'm receiving a little bit more with this than with the dongle. Look, in essence it works, it does receive, but whether this receives better than blue dongle that we've tried before, that's yet to be established. I guess we need to connect a proper antenna. We are indoors and the reception over here on a little epoxy antenna like it was supplied with is not going to be very good. However, as a kit, this was quite challenging and at the same time very satisfying. So tiny little wires to the legs of the IC, it's not the simplest. It's the first time I've done it ever, but it worked out, so I guess it's not that difficult if you have got the patience. Yeah, just be aware. But nonetheless, it was great fun to build, so I hope you enjoyed the video. That will be it for this one. I'm not sure how it's going to work out in editing. I hope it's going to be manageable. Nonetheless, thank you very much for sticking around. Please do check out the links in the video description. And for today, that's it. Take care.